So the ion chair, I got the EMF meter out. That's the Bolerian apparatus. Yeah, different subject. In any case, let's see. So it's set to the 0-100 magnetic, and that's the 0 to 100 milligauss. And this will show the magnetic field, and then I'll flip it over here to the electric setting, and that will show the electric reach field. And then I'll also show the RF, which is the bottom here, and there will be no field. The magnetic field is generally contained directly in the space between the top and bottom electrodes. Come out beyond sort of the edge of the chair here, and it'll drop off. The electric field, on the other hand, extends over to the corner of the garage over there, which is, I don't know, 10, 12 feet, 15 feet, something like that. And then there's no RF field. It's all electrostatic, and the magnetic field is directly induced between the two high polarized plates, which is curious. So I'll turn it on. We'll start with a magnetic. Off the chart, right on the arm of the chair. Be careful so I don't hit my head on the top of that. Alright, so if we back it out. Let's see. So we're about 1.5 feet away from the chair. Milligauss is around 10 on that nonlinear scale there. Right? The front. And about the same out. Getting a little closer actually. Right? Take that into the center of the chair. It's off the chart from the seat. You see it drops right here, which would be around my heart or neck, somewhere in there, throat. You see it kind of just dropping into pulses up towards the high, and this is the top where my head would be, the top of my head, which looks like it has the least magnetic field. Pulsations up at the very top here. Might be the torque of the electrostatic field, right? So let's flip it over to the electric. Alright, that's on the electric field. And just walk backwards from the chair back into that corner I aimed it at earlier. And there it starts to drop off. Alright. It's a big reaching field. It takes up pretty much the whole garage in terms of an electric field. Alright, so now I'll switch it over to the RF. And you'll note there's absolutely no RF field present. You can walk it back into the device. Alright, all the way in into where the magnetic field is noted, along with the electric field, which are both off the charts. There's absolutely no RF. Radio microwave. And yet there's a very decent magnetic field in the middle here, and an electric field that's off the scale to about 15 feet away from the chair while it's turned on at 50,000 volts. So remember, that's 925 volts an inch between the 54 inch gap between the plates here. Go ahead and flip this back around to the magnetic, just so you can see when I turn it off here, it's off. No more electric, no more magnetic. There's still a residual electric, takes longer to bleed off, huh? Cool. Looks like that might be detecting me. If I go and grab the meter, it goes up. So I have some kind of an electric field on me, I guess, now, from being in the field. That's an interesting thing, huh? Let's see. I hadn't noted that before. That's after sitting in the field there for a few minutes. Huh. Just settle down. It's a bigger electric field. Take my hand off them and it goes to less than what it was when I held it. Interesting. That's what the ion share does. It'll be interesting to see if I can actually measure that magnetic field that's being generated in the middle with the coil set up to intercept it. I don't know how big of a coil I would need, or actually I guess it doesn't matter. It depends on if the actual scope will work without being affected by such a high electric field, which